In this lesson, I'd like to go over the derivation of the axis of symmetry for a quadratic using completing the square. In another video, I show you a derivation of this x is equal to negative b over 2a using the midpoint formula. But today, I'm going to show it to you using completing the square. Okay? So the goal of today is we're going to try to force this standard form of the quadratic equation into a form that looks more like vertex form. Okay, so the vertex form of a quadratic equation is a times x minus h squared plus k. All right, where h is our axis of symmetry or our x value of our vertex, however you want to look at it. Okay, so we're going to try to make this standard form look like this vertex form and then try to discover what h may be. All right, so let me just rewrite our standard form here and get started. Okay, so the first thing that I am going to do is I'm going to remove my a from both of these terms, my ax squared plus my bx. And you'll notice that bx does not have an a, but we're just going to go for it. All right? So if I take an a out of ax squared, I'm just going to get x squared. If I take a bx, or an a out of bx, I'm just going to get b over ax, right, to make that be 1, okay, plus c, right? I didn't do anything to my c term. All right? Now, we're going to try to make this ax squared plus b over ax. We need another term to make this into a perfect square trinomial. Again, see what we're doing. We took out an a because that's what we're trying to make it look like this form. All right? And we're going to try to make this x minus h squared. We're going to try to make this into a perfect square trinomial in order to get it to look like this form. So, how do I do that? Well, I take 1/2 of my b term and I get b over 2a. I'm just going to star that because that's what's going to go into our vertex form here. And then I'm going to square that, all right? b squared over 4a squared would be squaring that, correct? Okay, so that is what I'm going to put in my equation now. To get that perfect square trinomial. Ooh, I'm running out of room here. I'm just going to start a new page. All right, so we had f of x is equal to, I was making that perfect square trinomial. Now there's a problem here. I just added this term, b squared, or actually a times b squared over 4a squared. So I'm going to have to subtract that term as well to keep it equal. So I'm going to subtract a. Remember, this is a times b squared over 4a squared. b squared over 4a squared. I'm running out of room here, but that's okay. All right. And now we can see I have an a here and an a on the bottom, so maybe I could cancel those out. But first thing I want to do here is I know that this perfect square trinomial, I know that I can factor that into x plus b over 2a squared. And that's why I starred that b over 2a when we were completing the square earlier, because I knew that that was going to be a term in my binomial here. Plus c minus a times b squared over 4a squared. Okay, so I can see here I have an a and an a, so I can just make that, just have one a down there, actually, cross that out. So now I'm going to have a times x plus b over 2a squared plus c minus b squared minus 4a. Okay. Now, what do I notice here? What do I notice? This sort of looks like my vertex form. All right. I have an a here. Then I have something that sort of looks some binomial squared, and then plus k. Maybe this is k. So this actually is my k term, right? And my h term here. All right. So this is going to be my axis of symmetry, or my x value for my vertex. Well, I have a b over 2a squared here. However, I noticed that the vertex form is a times x minus h. So in order for us to say that, say what h is, it's going to have to be a negative b over 2a. Okay? Because in order to get this positive here, I would have had to have a negative times a negative. So that is how, another way to look at how we get our axis of symmetry for a quadratic.